I'm glad to welcome you back to our Staadpro class. We did a general overview of the Staadpro workspace in our last workshop, and this is our file, steel truss 1. So we open it up, we say okay. Beautiful. Like what we said in the previous video, this is our structure tree view. Okay, you move from top to bottom, starting with setup. You go to geometry, go to general, you go to analysis, and then you go to design. So this is the flow of how the software works. First of all, do your general job setup. Then in your geometry tab, you do your modeling, and then in your general, you are assigned loads and supports, and then you analyze your analysis/print, and then you design. Okay, if it is steel, you work here. If it is concrete, you work here. If it is timber, you work here. If it is aluminium, you work here. And if it is shear wall, you work here. This is how the structure works, the software works. Sorry, and this white area here is your modeling space. So Staadpro is a three-dimensional software, so you can see your XYZ coordinate here, but you can put it in 2D environment by tapping any of these views. Okay, you can see your cursor, your UCS is now in XY, which is 2D. Okay, you can view from several area or from several sides, and then this is your isometric view, which takes it back to 3D. And then you have some important tools here, like the add beam tool for adding beam. Okay, the add four noded plates for adding plates using 4 points, and then add a surface, yes, for adding surface using any number of points. Then add 8 noded solids. You can actually add a solid figure with 8-sided nodes. Okay, snap node / beam. Okay, insert node. Okay, generate surface meshing. Okay, insert openings in the surface. Then translational repeat. Okay, you can mirror something to the other side. That's what we call translational repeat. And of course, we have cyclic repeats. You mirror in a cyclic form. And then of course we have generate mirror, generate rotate, and then fill floor grid with plates. Okay, you use this to add slabs in concrete and steel slab analysis and all of that. So these are the major tools that we use for our beam, plates, column modeling. So we are going to really enjoy the software. You should just sit back as we go through modeling, analysis, and design. So very quickly, we go to our setup to start. Okay, we are going to be modeling this truss shown here. All right, so in our setup, we can put our job there, steel truss. Okay, steel truss. Okay, 001. all right, meaning is our first steel truss job. Then our client is A and A Limited. Job number is 001. Okay, revision none yet, parts none yet, reference. Okay, design engineer, AKP, that's design engineer. Then checker, HO. Then approved is also HO. Okay, we can fix up comments later. Okay, just hit save and then just hit save as. Okay, we've already saved as before, so just hit save. So yes, so these are our job information, or our job setup. Like I said before, we are going to model this truss. You know, it has 1 2 3 4 5 6, okay, 6 bays. You know, 6 times 1.5 gives us the entire length of the bottom as 9 meters, and then the height of the king post is 3 meters. Okay, all right, so let's go back to Staadpro and model. Meanwhile, this bottom steel member is called bottom cord. This top guy here is called rafter. This is also called rafter. Then in betweens we have vertical and diagonal bracing members, and then of course this one here is the king post. So okay, we model in our geometry tab. Okay, so in the next video we are going to carry out our modeling proper. Thank you for watching and see you in the next video. Okay, I'm glad to welcome you back to our Staadpro workshop. We're going to be modeling this truss, and we go this way. Okay, right here in our geometry tab, in our geometry tab, like I said before, it's either we use this grid to model, or we close the grid completely and use the coordinate entry method. So let's go ahead to close the grid completely by hitting this cancel button there. All right, we saw that we have bays of 6 bays of 1.5 each, and if you put this in your view from Y, okay, view from Y, take it to 2-dimensional view, you see your UCS. Okay, let me put on isometric again. You see your UCS is in 3D, but if you put it on view from Y, see your UCS will change to 2D. So everything in this horizontal plane is X, and that's where you have your base of 1.5 in 6 places. Okay, and then anything going up the Z axis, that's vertical. Then anything going into the modeling area is your Y. So Y will not be considered here because you can only move in the X and in the Z plane. So very quickly, our first point will be 0, 0, 0. So 0, you can use your tab. So they are all zeros. So from our truss here, this is where we are presently. So moving down here, you would have moved X 1.5, but we are not going up, so we are not moving Z, and neither are we moving in. This is what I'm saying. This is your X, so you are moving X 1.5. You are neither moving up nor moving in. So very quickly, our X here is 1.5. You know, we specified that our entry will be in meters and kilonewton at the outset, remember? So use tab to go forward. They are all zeros. Now moving straight to the next point. Okay, let's look at our AutoCAD drawing. Now we're moving down to this point. This is our reference point. So moving from here down to this point, you would have moved x 1.5 plus 1.5, that's 3 meters. You are neither moving y nor z. So here you have 3 meters for your x. Good. So moving to the next point, all right, will be 1.5 plus 1.5 plus 1.5, because this is where we are moving to. And so x will be 4.5 and y and z will be 0. So going to the next point, you agree with me that x will be 6 while all other points are 0. And going to the next point, you agree with me that x will be 7.5 while all other points will be 0. Going to the next point, you agree with me that x will be 9, which is the final point. X will be 9 and y and z will be 0. Now if you go back to your AutoCAD drawing, we have gotten to this point. We have 1, 2, 3, 4, 5, 6, 7. So go back to your Staadpro model, you have 1, 2, 3, 4, 5, 6, 7. Now you notice that at this midpoint, when x moves down to this midpoint, y will now move 3 to give you this nodal point here. So here x is 1.5, here is 3, here is 4.5. That means if you want to get down to this point, you move x 4.5 and then y 3 meters. Sorry, and z 3 meters, because z is actually going up. Look at this. So x 4.5 and then z 3. Meanwhile, y will be 0. So x is 4.5, okay, y is 0, and then z is 3. Good. So that gives us our desired point. Now you click on the model, you click on the modeling area so that your tools here will not be grayed out. So I click on the modeling area. For example, if you click on one of your cells, you find out that your tools here are grayed out. You cannot click on any of them. So if you want to click on your tools in this area, you have to come back and click on the modeling area. So now we are going to pick up this tool in your main toolbar called Add Beam. So with that tool now, you can now add your beams. Okay, can close this up. Okay, so you've added your bottom rafter and then your top rafter. So very quickly, we have to add the node points on our top inclined rafters. Okay, so we are going to do that in the next video. Thank you very much for watching, and see you in the next video.